Saxon's Calculus Lesson 9, Abstract Word Problems. As you will expect, abstract is filled with letters, not necessarily with numbers, or at least the bulk of the problem is in letters. There might be some numbers, and they're going to be word problems. So example 1, Linda drove m miles at p kilometers per hour, but got to the flower market late. Rate times time equals distance should be the formula I think of immediately. She drove m miles, that's the distance, at p kilometers per hour, that was the rate. And so if I solve for the t here, the time would equal m divided by p. But it said that is arriving 2 hours late. So if this had been like 5 hours, she should have gotten there in 3 hours. So what I need to do is subtract 2 from this time to arrive on time. How fast, so same equation, but now how fast, I don't know the rate, should she have driven to have arrived on time? And the correct time, we just said, was m over p minus 2. And did her distance change? Nope, it's still m miles to, what was it, a flower shop? Flower market, there we go. All right, so we basically just need to solve for this r. So we're gonna do a common denominator here. So that's going to be p, which means I put a p up top. So this is m minus 2p all over p. And then I'm going to go ahead and write this as a fraction because I know that my next step is to divide this to separate it from the r, which means it flips and multiplies. I just wrote 2 and I meant p. M minus 2p. Now, when we solve, the rate is mp over, and the 1 doesn't matter, so m minus 2p, and that was in kilometers per hour. Per hour. There we go. And just double checking the answer. Yep. So that is the rate she should have traveled. Now, example 2. Jill could do 3 jobs in J hours. Sharon could do S jobs in 5 hours. Okay, so the rate for Jill is jobs divided by hours. 3 divided by a J. That's going to be, I don't want to confuse the capital J for Jill with this J. That just happens to be the way it is. And the rate for Sharon is S jobs in 5 hours. Again, that S and S combination, whatever. How long would it take them to do W squared jobs if they worked together? So now if they're going to work together, they're going to have 3 over J plus S over 5. I don't know how long it's going to take because that's what it wants to know. And now they want to accomplish W squared jobs. So I need a common denominator here, which will be 5J. So this one needs to multiply by 5. This one needs to multiply by J. So we have 15 plus SJ over 5J T equals the W squared. And again, I'm going to make it a fraction over 1. Flip that when I divide it. 5J over 15 plus SJ. So our time is 5 W squared J. Again, that order doesn't matter, but the number should go first. 1 isn't changing anything, so 15 plus SJ. And then the time would be in hours. Just double checking the answer. Yep, in hours. Okay. That's example 2. Example 3. Ryan and Steven saw that the number of cookies varied directly. So as soon as I read that, I know I'm going to do that fraction, cookies 1 over cookies 2. Varied directly with the amount of sugar. Directly is going to keep sugar 1 over sugar 2. And there's no other part to it. So now fill in the numbers. If 5 pounds of sugar is used, so the first sugar is here, D cookies were produced. So the first amount of cookies is D. How many cookies, so cookies 2 is what we're solving for, will be produced if 10 pounds of sugar is used? So 10, is that multiply with E? Yes, 10 multiplying with E. And now we cross multiply to solve for the second cookies. So that's D times 10E, so 10DE is divided by the 5 to equal the amount of cookies. And then I do need to simplify those numbers. So cookies 2 should be 2DE. And I guess technically I should probably write cookies with that because it's a word problem and it should have an answer, not just the C2 equals. Okay. Now, example 4. Ryan and Stephen's little sister found that she could buy Y items for D plus $6. Change space here. So I remember that it's rate times the items equals the money that I spend. It's just a tweaking of the rate times time equals distance. All right, so she could buy Y items for D plus $6. So I want to solve for the rate here, which means the rate is D plus 6 divided by Y. And we're going to use that rate to determine how many items she can now buy for $42. Because I know this is a fraction flipping, I'm going to go ahead and write the over 1. And then this is going to multiply by Y over D plus 6 when I flip it. So 42Y over D plus 6 items, because I always need an answer with a word problem. Okay. And then example 5. This year, Steve is twice as old as Tom. So at the moment, Steve is twice as old as Tom. He is older, so that would put the 2 with Tom to make it balanced. In X years, Steve will be, so X years, so Steve plus X years, he will be 5/3 as old as Tom will be then. Now in this wording, they're giving you a clue that whatever you do in the years in the equation, you have to do to both. And they worded it this way, and this is a good reminder, but they don't always. Sometimes it'll just say, in X years, Steve will be 5/3 as old as Tom, and it's implying Tom in that amount of years. Find the present age of Steve in terms of X. Well, obviously we have an X in the problem, so we're a little bit stuck there. So I need to substitute, not eliminate. So where I had an S, we're going to plug in this 2T instead. Now I have T's in the problem and the X's, which I know are going to be the answer part. So I want to get these T pieces together, but first I need to distribute. So 2T plus X equals 5/3 T plus 5/3 X. Now let's move this 5T over by minusing it. And I'm going to go ahead and do the common denominator here, which is going to be 3. So this one is going to change to a 6. 6 minus 5, so 1/3 T. Move the X over, which is minusing a 3/3 X if I give it a common denominator. So that equals 2/3 X. And then we're solving for T. So we're flipping and multiplying 3 over 1. So the 3's are going to cancel and just leave me 2X. But the question didn't ask for Tom. It said find the present age of Steve. That's why the book did their substitution backwards, but you can still solve for whichever one and then plug back in. So to get Steve, you're just doing 2 times this one, and 2 times 2 is going to mean that Steve is 4X. And technically in the word problem, it should say years old. They didn't write it, they just said S of n is 4X. Now, example 6, their last example in this lesson. Gary had G gallons of a 60% antifreeze solution. Oh, before I continue this one, this you need to remember is percentage times amount plus a percentage times an amount will equal a percentage and an amount. And the key with this amount is it must equal the total of the two amounts over here. So Gary has G gallons, that's my amount, of a 60% solution. So I'm going to write that as 0.6 in its decimal form. G gallons of a 60% antifreeze. Ed had E gallons of, okay, just a second. Let me keep reading. If the final solution is 40%, write an expression in terms, yeah. Okay, so we're adding to what Ed has, E gallons, that's his amount, of a 30%, so that's 0.3 times the E. And then I am also, as I read this, I'm double checking that the percentages are all about the same thing. I can't talk about antifreeze and then water in the same equation. So if this percentage is antifreeze, all the rest of my percentages need to be about antifreeze. And so 30% antifreeze. If the final solution is 40% antifreeze, 0.4, write an expression in terms of G. So in other words, we want to ultimately solve for the G that represents the number of gallons Ed added. All right, so again, I told you that the amount on this side has to match the amounts over here. So those were G plus E. And now we have our actual equation. We're going to solve for the letter they wanted, G. So we've got 0.6G plus 0.3E equals, and then I need to distribute 0.4G plus 0.4E. All right, since we want to solve for G, this one needs to come over and join. So 0.6 minus 0.4 is 0.2G equals 0.4 minus 0.3, 0.1E. Because I wouldn't want to just say point E, that would be extremely confusing. And then G equals, divide by 0.2. So on the calculator, that should, now I'm looking, they didn't do, they changed theirs from the decimal form over to whole numbers. You can do that, or you can leave it in decimal, work it on the calculator. But either way, I should be coming up, oh, no, hang on. No, they didn't. They did solve for the G, and that was how much Ed added. Yes, all right, so this is 2, and so this tells me that Ed is adding twice as much as Gary had originally added. So the question, make sure I answer it exactly, represent the number of gallons Ed added. So how much, so he added 2 gallons to what, yeah, Ed had. All right, that works.